Hello, welcome everyone to one of our sessions, GSMA, Leveling Up with the 5G-Enabled Drones. This session is one of our series as part of the GSMA Drone Interest Group. So again, welcome. So we are now, before we go to these slides, I wanted to introduce us to one of the chair of the Drone Interest Group, which he will give you an introductions and then guide you through the agenda of today. Before we do that, if you have any question during the presentations, please feel free to put your questions on the chat, and we will do our best to try to answer all your questions. So with no further ado, I want to introduce to Alexander Prokaski from TELUS, which is one of the chair of the DIG, and he will get you through the session. Alexander, over to you.
Thank you, Barbara. Welcome everyone to GSMA Drone Interest Group Deep Dive session number 4, if I recall properly. Today, we want to give you an opportunity to see what has been done or plans regarding the 5G technology as a backbone for commercial drone usage. Collaboration of Ericsson, TDCnet, and Connect44. We're going to have Frederick Flirin, Lin Wen, and Kapil Mittal from Ericsson, and Peter Hansen from Connect44 as a first presentation for us. After that, we're going to have Stefano Fancin from Qualcomm, also kind of working capacity of ACGA, lead of one of their groups, and he's going to give us the updates related to the release 19 directions for the aviation vertical from the 3GPP perspective. Without any further ado, I would love to hand in the floor to the Ericsson Connect44 team.
I'm from Ericsson Drone Mobility. We will also have Kapil and Lily presenting. And then we have a special guest, as Alexander mentioned here, Peter Hansen from Connect44. So I will talk briefly about the background a little bit, why we started this and so, and then Lily will fill in with the details of the specific, more telecom related use cases. And lastly, Kapil will mention a little bit about the business case, and Peter will talk about this from a Connect44 perspective. Next slide, please. So we know that there are multiple stakeholders in the aviation industry that have connectivity as part of their core through conventional and emerging technologies. But it's also important to understand what are these connections and what requirements are we as an industry expected to deliver and for what purpose. Drones and other UAV mandates seamless connectivity and capacity at altitudes that traditional networks haven't previously served. And the emerge of 3GPP cellular technologies like 4G and 5G provides an answer to this to support high-performing airspace connectivity as well as meeting strong regulatory requirements, enabling safe coexistence here between aviation and telecom. We have decided to focus on drones, being close to the ground, operating outdoors, and thus in need of wide area mission critical connectivity. They appear as a next logical step for growth for a mobile network operator. Next slide, please. So I guess we all are familiar with this, but there are some problems for the drone enterprises today to fly beyond visual line of sight. First, most of drones today, you cannot really fly them longer than 3 to 5 kilometers in best case with existing technology. And drone systems today, they do not have enough information to fulfill the BBLOS regulations in the future. And there are no real secure solution to stream the data from the drone to a secure location. So today the data is usually stored on board the drone on the memory card. So And if a drone falls down, you can lose your data. And of course, from a society perspective, when you see a drone as a private person today, there is no way really you can find out who's flying it and for what purpose. And that needs to be solved as well. We know that the drone ecosystem is still quite new and in some parts a bit immature. And we see a clear need for standardization in the drone ecosystem and collaboration between the drone ecosystem and the telecom industry. And we believe that the intelligence that we can get out from telecom networks can play a very important role in helping drones fly safely beyond visual line of sight. So a little bit, next slide, please. A little bit of a background on EDM then. So Ericsson Drone Mobility, EDM, that is now a cloud-based platform which gives the CSP an opportunity to become a key player in the drone ecosystem by offering as a service solution that enables enterprises to manage their existing fleet of drones using the telecom network to stream data and photos in real time. And also the ability to remotely control drones over the network, plan missions, etc., as a typical ground control station. And we have already started to utilize the network. So we have been engaging in trials like this with TDC Net that we will talk about a little bit more in detail to discover what benefits do we bring from the network that can be consumed through network exposure APIs for basically anyone who is interested in this data. So the main focus of EDM is to consume network intelligence to make drone flights more safe and lower the risk, and introduce some kind of automated permit solution for BVLOS flights. And EDM also makes it possible to dynamically control the network behaviors through the network exposure interfaces. So we can manipulate some parameters in the network. And going forward, I believe we can find more things to do here. So in the ongoing trials, and we will talk about that a little bit later, we have started to provide drone authentication and identification, drone network location, or route planning that can avoid bad coverage and people on the ground. We can change the quality of service using network exposure. We have also done some initial integration towards UTM system. So now, if possible, I would like to play the video, which is an introduction of EDM. This was the video that we showed at MWC this year, so some of you might have seen it before.
Imagine enterprise drones flying beyond visual line of sight, securely and efficiently, authorizing response and real-time decisions to critical emergencies. With Ericsson Drone Mobility, it's possible. Regions worldwide are experiencing longer wildfire seasons as a direct result of climate change. In forest fire response, time is of the essence, and drones can play a vital role in gathering situational awareness, locating and controlling hotspots, and directing the efforts of firefighters faster. Leveraging mobile network intelligence, Ericsson Drone Mobility's cloud-based drone mission control platform empowers decision makers to connect and control drones securely using telco-grade encryption, data security solutions, remote control, and live streaming of drone data. Ericsson Drone Mobility uses open APIs from mobile networks and aggregators like Vonage to help drone operators complete their missions and comply with beyond visual line-of-sight regulations. Mobile network capabilities like positioning, authentication, and performance can help drone operators monitor in real time and fly more safely by avoiding crowds of people and areas of poor connectivity. At Ericsson, we partner with mobile operators in building three-dimensional 5G networks and mission-critical infrastructure that will help realize the full potential of the drone industry and the broader UTM ecosystem so that the imaginative becomes possible.
As you saw in the beginning, we focus on the use case, wildfire, and then at the end of the movie, you saw the more network-related things that is connected to what Lily will talk about a little bit later. And as we have seen I mean, in the previous slides here, there are several key challenges that we need to address, and where mobile operators have a very important role to play, and of course, a great business opportunity for network exposure and monetize on network capabilities in a new way. So the red marked requirements here are some examples where the mobile network can play a very important role towards the future. I would also like to mention the GSMA white paper that we published together with TDCnet that is available on the GSMA Foundry webpage. So if you want to read even more than Lily will talk about, I recommend to read that white paper. Now I will hand over to Lily Wen, who will present in more detail the use cases that we did in the trial together with TDCnet. Thank you.
Thanks, Fredrik, running us through the introduction and also the great exciting opportunity to monetize use space in the new fashion. And yeah, now I would take you a bit further with more insight into the use cases itself. With a bit of backgrounds that Ericsson Drone Mobility together with TDCnet has performed a real-life test of autonomous operation with drone in the TDC macro network. And we have also exploring how the telecom APIs for connectivity and also beyond connectivity could be utilized by our partners in the drone ecosystems. So of course, when we talk about telecommunication, we first talking, actually next slide, please. Yeah. Thank you. Yeah, so yeah, this is actually the 6 use cases that we will be bringing with you. So for the first area, of course, we have the 5G network reliable connectivity. And in here, we are talking about 2 use cases, both use quality of service and also secondly, using the network slicing with the device level observability. When we are working with our partners in the drone consortiums, we have been realizing that the 5G can actually provide much more capability beyond the connectivity itself, serving both for the automation and also security purpose. So that's coming up with the next 2 categories that we will bring to you will be the UAV flight management and then the UAV flight security through 5G. In the UAV flight management, we will be taking on the automatic drone identification and also how do we do BVLOS drone remote control. On the UAV flight security through 5G areas, we will be also exploring into how could we using 5G to enhance the security and reduce risk for the drone operation by both on the drone location tracking with different types of 5G technology and also with the geographic SIM density map that will be introduced. Now we will start to looking into more details of each use cases, starting with the connectivity parts. Next slide, please. Yeah, so we are now with the network quality for individual drones. It can be controlled actually by EDM through a network exposing service, as Fredrik mentioning earlier. The quality actually can be controlled by users on demand according to the flight mission. For example, we have a flight that inspecting a tower. Then when at the tower inspection location, the quality of these drones can be upgraded instantly by the drone operators in real time when it's at its location. And while requesting actually from EDM for higher quality requests, a dedicated barrier is established with the defined course for the specific video streaming quality request. So now we will be also looking a little bit into the examples of how that look like. Can we have the next slide? Thank you. So on this slice, actually, you can see the difference actually before and after the quality of service triggering on the EDM. When we on the location of that location, we dynamically through EDM controlling the TDCnet, the network quality exposing, and then upgrade the qualities instantly. And in the network, we can see instant the network quality quality connectivity established. And then from the platform, we can see actually the image upload has instantly resumed from a buffering stage. By comparing these two pictures, you actually can see, of course, more sharp pictures on displaying on the TDC net logos on the right-hand side. Next, please. Now we would be like to talk a little bit on the second use cases with the network slicing. So from a drone aspects, of course, drone has a lot of kind of critical communication, such as control signaling, location reporting, live mission video stream through its mission needs. This all requires a reliable network connectivity. So in these cases, we have been utilizing the enterprise's end-to-end SLA solutions deployed in TDC Net macro network to cater on a drone critical communication together with EDM. The drone flies actually connecting with EDM through a secure slicing with a secured uplink network capability. And beyond that, we can see the observability in the network for this drone in real time, which is actually the pictures that has been showing on the right-hand side. The observability actually can be seen for each drone in real time over the monitoring in the picture. And you can also see through the pictures on the, especially on the lower histogram, it is uplink. So we can see a very static uplink, static flat line has been provided through the network slicing to provide its reliable quality. Next, please. Yeah. So now we are coming into the territory of beyond connectivity itself. With the drone flight approvals, actually nowadays the situation is it normally takes actually days or weeks to have flight approvals of a drone. So when we have increasing numbers of drones that are in the airspaces that probably would be want to have a BVLOS flight, then the identification of these drones becomes critical for both safety and also operation reasons. So a scalable identification actually is needed or asked from the industry. And it can be realized also through via a telecom network with high reachability and also with a multi-factor authentication. Here, this demo, we have been providing one answers with the network remote ID that utilizing the drone service SIM information, providing authentication and authorizations for both the telco network service and also the UAS service providing by EDM. So eligible flights can be authenticated and authorized instantly. However, when it's a non-eligible flights, it will be rejected and prevented from a pre-flight stage. So with this kind of things, it will be helping with automatic in a large scale for the drone identification. Next, please. In BVLOS situation, of course, we would require a remote control to have the drone flying. So in this case, we have actually tested the remote control of BVLOS fly through the 5G network with real-time camera surveillance and also a location tracking. You can see actually on the right-hand side on the pictures how the scenario is. So the remote pilots actually can see remotely on the real-time drone surroundings by the drone cameras itself, of course, and also it can be tracking the drone locations real-time on the location map. He can request actually the remote control from the ground pilots and take over control from the drones through a cellular network. So the test has been done actually through the nationwide from Sweden to Denmark in a long distance. And of course, when in a specific now we can start doing with the BVLOS permission areas. And in this kind of areas, the mission actually can be fully taken by a remote pilot without the ground pilots with empowered by this kind of technology. Next, please. So now we are also with the maturity of the airspaces, use spaces creations and the regulations. Two aspects become very important. One is location tracking. The other thing is SORAS of risk mitigations. So first we have a look here on the drone location tracking with different kind of 5G technology. This is including the 5G RTK GNSS of 3GPP, and then also through the network estimated location. We have been testing with the 3GPP RTK GNSS. It is observed actually with a less than 2 centimeters accuracy in a 3D with our partner SDU flight test. And what does it mean is at like this even with a centimeter accuracy in the altitude level, which is very crucial for a lot of drone operations. This actually could be used for accurate navigations and also the monitoring in 3D, which in this case is including the altitude. Furthermore, we are looking at the advanced 5G network estimated location. This technology actually can provide with a reliable second source location to validate the satellite position and fallback location when the satellite position is not trusted or it's not available. Since the you can see actually since this location is actually detecting and generating by the network, therefore this location is trustworthy and it's not possible to spoof. So this, if you can see on the left-hand side corners of the pictures, you can see actually the dot is RTK GNSS positioning location, and the circle itself is providing by the 5G network estimated locations, which is validating whether the drone reporting it is well, basically claiming where it is and validating the locations. And this will be very important for regulators also to understand that the drone is saying, claiming where it is for the safety reasons. So for the next slide, please. Thank you. Last but not the least is the geographic SIM density map. So with the SIM density map, the drone currently the SIM density map actually utilizing anonymous estimation of users showing real-time population density situations on ground and the people movements around it. This is a strong ask actually by the use basis safety regulations on mitigation on the risk on the ground risk. So on the diagram actually on the right hand side you can see it highlights the user density that higher than hundreds in the defined areas. And the darker the color it is, the higher the population density itself. So this can be providing as a tool that to real time looking at the ground risk and then basically providing from the UAS operators as a mitigation to the regulators. By using this kind of data, it's not only dynamically showing the ground risk, ground population situation, but it will also shows accumulating from this data. We can also see a static situation of this ground risk in the area. Therefore, this will be a great source providing towards the regulators as a foundation. So now I would like to, it's the end of all the 6 use cases. However, I would want to hand it over to our CEO, Kapil, to take us through the CSP go-to-market business models. Kapil, please.
Thanks, Lily. So as you could see, both Frederick and Lily, they presented our work done with mobile operators to understand that beyond connectivity, what other assets are there in the network. I mean, there are quality of service, there are areas to mitigate coverage and further help the drone operators for better mitigation of the flight paths. And I think working closely with mobile operators as well as drone ecosystem, I think the collaboration is absolutely very key. And that's where it defines what roles mobile operators can play. Been working with TDC Net in Denmark, Telia in Sweden, Vodafone Group, and many of them have started to realize what role they can start the market with. Some of them, for example, are looking at providing pure connectivity. It could be a simple SIM or even prioritized SIMs, to which provides a little bit more quality of service for drones. Others are also thinking how best can they start leveraging the APIs that they have. For example, Proximus in Belgium, they've started to understand they have a quality of service which they would want to leverage and provide it to the drone ecosystem. And they could either do it themselves or API aggregators like Vonage can help them to extend those APIs towards the drone ecosystem. Further up the value chain, mobile operators are thinking perhaps can they also tie up with drone mission control platforms like Ericsson Drone Mobility who understand their network APIs and then further expand it to their enterprises. So there are multiple roles that mobile operators are evaluating along with the enterprises. On the left, you also see the different value chain propositions, uh, right? Starting from connectivity to data. Some of them are also understanding if they have a role to play in being a USSP player, for example, or how can they further strengthen the UTM players in the market. In our discussion with Telia in Sweden, that's something that Telia is also evaluating how further they can strengthen the UTM players in Sweden and Scandinavia. The best part of the drone ecosystem currently is that even the enterprises are trying to understand how they can get benefited from mobile operators to further strengthen their cases. On the call today, we have Peter Hansen, who is the CEO of Connect 44, one of the most innovative organizations in Europe. Let's hear from him how he thinks the drones can help in his operations as well as how BVLAS can help him and his organization going forward. Peter.
And thank you, Kapil. I think we go to the next slide. Yeah, just 30 seconds about us so you know why we're actually doing this. I've already been introduced on a day-to-day basis. I'm in the Nordics, looking after Denmark, Sweden, Norway, but part of Connect 44 group in Europe. We've been around since 2000. We have today a very flexible muscle throughout Europe doing a lot of end-to-end rollout. We have everything in-house, including what we are talking about today. We're doing network planning and design. We're building networks, rolling out networks, maintaining networks. We are doing a lot of network management throughout Europe. We have invested heavily in automation, and that's actually our reason for taking part in this, because we see this as a necessity to step into this kind of new environment. It's been here for a while. It's been said already. It's still early days. But what I'll talk to you about for a few minutes is our experience from using it. And next slide, please. A lot has already been said, and our, let's call it down-to-earth experience as part of our automation journey has been to achieve a few things like working smarter, working faster, being able to optimize our logistics when going to site. Today we have all our own pilots. We have our own digital twin platforms. Last year we did about 1,000 flights on mobile infrastructure. This year we will do about 2,000 to 3,000 sites, depending on weather. We are inspecting both the active and passive part of the infrastructure today, and the output we are collecting is being used for the digital twin, but a lot of maintenance reports, inventory checks, line of sight checks, panoramics, stuff like that. What we have found is it really makes us a lot more efficient, having the ability to control the drones remotely. You have the highlights here on this slide. We have the possibility to load more site inspections per pilot. We get a lot of efficiency through this remote control function because we have a fast support. We have people sitting in our offices supporting our pilots in Denmark, Sweden, Norway. So it's also got to do with having the knowledge in-house, not having to copy paste it into the different teams in the different countries. We can actually have like an experienced team in one location. The possibility for the live video streaming we have actually found very important, not on all site inspections, but on the VIP sites or the critical sites that suddenly pop up on any network. It's also planning the missions have become faster and easier for us over time. In the beginning, it was not, but today, if you have tried flying with drones, you have to have your different apps. They must be updated. You need to have different apps to certain drones. Now with the EDM platform, we have actually found that we have everything in one package. So we don't need to constantly having all these different apps up to date. We can actually rely on logging in and you have everything at hand, which makes our work more efficient on a day-to-day basis. So it's basically a one-stop platform for everything that has to do with flying our drones, whether it's controlling them, managing them, where are they, or optimizing the way we fly. So it has brought us a lot of advantages over time, and we see a lot more to come. It's going to be like a never-ending journey. And I think if we jump to the next slide. Yeah, again, some of it might be repeating, but we can use the platform for optimizing the way we plan our routing. In the traditional way, you have one guy, he goes to site, he sends out his drone. But now with the way or the ability to actually fly beyond visual line of sight, you can inspect more areas than today the traditional way. Also, we have the possibility now to have one pilot not inspecting one site, but maybe inspecting 2 or 3 sites. We are doing quite a lot of work in the German space at the moment, and we actually able to send out 3 drones per pilot using a platform like this, where you have support remotely. Also, this increased response time with the eyes on is a big advantage to us on a daily basis, because we save a lot of expensive people from having to go to site. Now we have our drone pilots. We hope to have small strategic silos that we can actually in the future send out the drones semi-automatic without having pilots going out there and having hands on. So the saving alone to us for having less people and increased response time means we are able to service our end customers even faster and better. It also gives us a more accurate way of planning our sites, designing our sites. Again, it's been mentioned, the accuracy of logging into the platform, flying on the platform, means that we don't have to worry as much as when you just go out manually and fly your drone, because you actually have eyes on. You have a logbook, you can see where the drone has been, you can document it, and everything is about safety today. So this trial really gave us the opportunity to dive deep into is this a way we would like to go? And it's definitely a way we would like to go. I would almost say it's a way we must go. Flying in Denmark and Sweden and Norway, we have a lot of borders to challenging neighbors at the moment, and we have a lot of restrictions flying with drones, and this platform is definitely one that could help us get faster permission to fly, and also avoid areas where we are not allowed to fly. Our pilots, as mentioned, they really become more efficient. They also feel more safe when they are flying because they can have eyes on in 30 seconds if needed. And it's always nice when you're out there flying to be able to talk to your colleague and say, hey, have a look at this. Should we do a second round? What do you think? Should we capture it in a different way? Because sometimes it doesn't look on site the way people thought it did. So the live support and this ability to have eyes on has helped us a lot. We see a big value on that. But also our customers, not on every site, but on some critical sites where you need to make a special line of sight between a couple of towers. This is really valuable. Again, the standardized way of accessing and planning our drone missions is probably one of the bigger values, because we've had a big challenge with keeping our apps up to date, keeping our drone fleet up to date with the ability for everything to talk together. And now this has been, or will be, eliminated in the future with the authentication and identification of the drones. So, and I think that's probably what I should say for now about it. It's been a real eye-opener. Using a drone today is the way forward for a lot of things, but using it with the ability to have this beyond visual line of sight just brings a completely new world to what you can actually do and how much more efficient you can be, and the added services from us to our customers. So it's been a real positive experience.
Thank you very much, Peter. Quite an interesting perspective and use of some of the capabilities developed by the EDM and underlying network providers for you. We are a little bit ahead of time compared to the schedule that I had. Do we keep the QA for Ericsson and C44 team at the end? Or we can take a few now.
Maybe I can continue just 30 seconds because I can see some of the questions that have popped in for me were about the connectivity, how important 4G versus 5G, and the answer to that is it doesn't matter what G we are talking about, but we do need good connectivity. So the connectivity is important, of course. If we can have 5G constantly, absolutely to be preferred.
Thank you, Peter. Barbara, then do we want to take a few QAs for this first presentation now, or we want to give floor to Stefano and leave that for the end? Okay. So maybe, Stefano, are you ready with your part, knowing we're a little bit ahead of time?
I am.
Okay, so if you don't mind, then I'll leave the floor to you to talk to us about Release 19 direction for the aviation vertical.
Yes. So, hello everyone. This is Stefano Faccin, Director of Standards in Qualcomm. I've been asked to discuss a little bit what is being done for Release 19 in ProGVP with respect to aerial vehicles. As a brief reminder, I will mention what was done in the previous releases of the work. So, since Release 15, a set of aerial features was introduced for the radio to support drones. And those features are really at the radio level and were mainly aimed at ensuring that aerial vehicles that use cellular connectivity do not interfere and, let's say, play well with the rest of the cellular ecosystem, because when flying vehicles connect to cellular network, there can be quite strong interference to the ground. So a lot of features was introduced. And in release 18, those features are now being replicated for 5G, since when we was done originally was done only for LTE. In release 17, we introduced a whole framework for drone authentication and authorization in cellular networks that apply both to 4G and 5G, plus a set of services the mobile operator can provide for location tracking, flight planning, and flight authorization for these devices, and to enable authorization on demand of the connectivity for command and control. Now, here I will be considering all of this was done. In release 18, also we introduced the use of Sidelink, which some of us know as PC5, for broadcasting multi-D and detect and avoid solution, and that work is pretty much completed. So I will just briefly mention what is being done in release 19. So if you go to the next slide, just as a next slide, please. So just as a reminder of the time frame, because not everybody is familiar. So if we look at the bottom in the yellow, you will see where we are. So we're well into the release 19 work. There are pretty much 3 meetings to complete that. So all the requirements are already in quite good shape. There is some work still to be done, and it's planned to be completed by the end of 2023, the requirement work. And then the resulting work in RAN excuse me, and system architecture will begin at the beginning of next year. So next slide. There are 3 areas that are important in terms of use case and requirement. The first one refers to UAV enhancements, and the second one is what is called dual steering, which is not per se focused completely on UAV, but it provides some building blocks for that. And the third one is integrated sensing and communication. Let me briefly mention each one of them. So the UAV enhancements that we're looking at for release 19, I would say that most of them are to provide a better interfacing between cellular networks and aviation service providers, whether they're the UTM or the UAS operator, or let's say a C2 CSP, and are meant to define some of the interfaces that will help with the pre-flight preparation and in-flight operation, like flight mission application, flight path determination, and this includes both the functions that will be needed before flight, as an example, estimating the quality of experience along a certain path, but also during the flight in terms of flight monitoring and controls to monitor the quality of experience and take appropriate action depending on the result of that monitoring. And just as a brief note, this actually reflects some of the work that has been done by GSMA and GotoMarket in ACJA with the network drone services for the interfacing, to be able to have these services that mobile operator can provide to the player in the aviation in order to do better determination for flight planning and verify the risk and the quality along certain routes. Also, we're looking at enhanced safety and security of drone operations, and in particular, the work for Release 19 focuses on what we can define as network-based or ground-based or network-supported detect and avoid. So a set of requirements and use cases has been defined where we can better leverage the information available in a mobile network that the operator can collect in order to support an overall framework for detect and avoid, in addition to what can be done between aircrafts. And the third aspect is redundancy and reliability of command and control for UAVs. In particular, here the scenarios focus on the idea that devices that are flying could be connected to multiple networks at the same time. And the main use case is one operator being used as the active operator, so the command and control and all the critical data is transferred over one operator, and the second network is more of a standby network to which the device can switch in case based on a set of criteria the connectivity is supposed to be better on the other network. As we know, some network provide in most cases very good coverage in every area, whereas in some other situation there can be the need to switch between networks, as example due to congestion or due to coverage issue. And this last point connects to the work of dual steering. As I mentioned, dual steering is the idea is not focused specifically on UAVs, but provides building blocks that can be used for these aerial vehicles. And it's really the ability to support mechanisms for steering and splitting and switching of user data between two different 3GPP networks. The last point is again not specific to UAVs, but there are some UAV specific use cases, and it's the one related to sensing. So sensing is a 5G system feature that enables to get information about characteristics of the environment and of objects within the environment. Using layman terms, imagine using 5G RF signals as a radar system that will able to identify what are the objects and the obstacles. So as an example, identifying where the flying vehicles are, what static objects are present, and all of these can be used to create an aerial map in real time and actually quite very well-defined fashion to be able to help with navigation, to be able to help with detect and avoid. Next slide, please. So in terms of UAV enhancements, I think I've already mentioned most at a high level, but the use cases that have been defined are UAV detection, and this relates both to aerial vehicles that are declared aerial vehicles that have a subscription to be the aerial vehicles, but also detection of flying vehicles that are not necessarily authorized or may not have a SIM card or may actually not even have 3GPP connectivity. There is aspects for supporting UAV pre-flight preparation, so all the planning for flight phases, but also use cases and requirements for geofencing for visual line of sight missions. And the other three that are here I've already mentioned, so the network assisted DAA, the 3GPP network as an information service to the UTM and the aviation functions, and supporting of in-flight operation. If you go to the next slide. So these are some view of the scenarios. So I think that the one is more important. Well, the first one is the pre-flight preparation. So this will be enabled on a mobile operator with enhanced services provided. So here we're talking about API exposed. It's something that Ericsson mentioned previously. Some APIs are already available. Some are more defined in a proprietary way. This will bring the work to be more open and standardized, to have all the APIs to be able to do this pre-flight preparation. The second one is network assisted DAA. The idea would be that the UTM, in collaboration with the operator, would be able to create a set of data that can be quite dynamic about what is actually in the air and what are the obstacles, and create tools to be able to inform both the flight vehicles that may have quite advanced automation, but also the US operator and the controller with information about what could be the obstacles and the risks on the flight path, and help with the tactical deconfliction. And the third one here, as I mentioned, is in monitoring. So this would be, again, the use of APIs to interface with the UTM, USS providers or the US operator to provide the realistic real-time data about what is the performance of the use of cellular link, and what is the actual quality of experience. Next slide. I just listed here, I think this preparation will be available offline. You can just take a look at them, but these are some of the requirements that are coming up. I highlighted some of the points, but I think I verbally mentioned most of these. I think some aspects that are very important here are for UAV identification, so to provide more precise information to the aviation functions about the U location identity, what is the actual flight path, and what are actually also the obstacles in terms of flying vehicles or static obstacles that may be on the path or that can create some conflict situations. Next slide. Here are some other lists. These are all the requirements that are being written now. I think we can skip more on the text version. I've already mentioned at the high level, so you can go to the next one. So the dual steering, as I mentioned, is not really focused specifically on UAV, but it has some important aspects that can be used. Specifically, if you go to the next slide, dual steering has been into GPP for quite a long time, but it was introduced to really do traffic aggregation, splitting and switching between 3GPP and non-3GPP access, so specifically cellular link and non-cellular link like Wi-Fi. What is being brought in now is actually the use of multiple cellular links, where the device may be using simultaneously or at different time multiple cellular links to have connectivity, and this can be done for reliability, for enhanced coverage, and scenarios where not all the traffic may necessarily be transported over a single network at any given time. So examples here could be the one that I mentioned before, where one network is used as the active network while the other one remains in standby, or scenarios where you can actually split the traffic. As an example, it could be that one network is used for flight critical traffic like command and control, telemetry, and possible navigation video, whereas the other network may be used more as an example for aspects like payload video. So the first network may transport the video that actually the UAS operator, the controller, sees that helps in navigation. But let's say if the drone, as an example, is flying a mission, let's say over a sports stadium, taking 4K video, the 4K video may actually go over a different network in order to provide overall reliability and quality of service. And I have, if you can move to the next slide, some examples showing the various scenarios. Notice that here you will see multiple slide scenarios where we're using both cellular and satellite connectivity. This is, of course, satellite via 3GPP networks. So there are scenarios that we're focusing on scenarios where we use multiple communication links of the same network. So that's why you will see it's written intra-peer element. So here there is one network being used by multiple links of that network. So here the use case was created for maritime, for dual 5G and satellite access for a non-autonomous ship operation. But some similar scenarios could be used also for UAVs, especially higher flying UAVs. And if you go to the next slide, there are scenarios where we might use multiple elements. So as an example, I listed the scenario of sports events or urban communications. And notice that here, when we say multiple links, it could be two cellular links of public networks. It could be the cellular link of a public network and a private 5G network. It could be satellite and a private 5G network, or it could be satellite and 5G. So all these scenarios will be supported. And again, the message is, though this is not really focused on the UAVs, some of the building blocks that have been defined here can definitely be used by the aviation field to improve reliability of the connectivity. If you can go to the next slide. Yeah, here there are some additional examples. All of these are applicable in various scenarios to the UAV. And once this work is done, there will have to be the work to identify which of these use cases can actually be relevant for the UAV. And with the main question being, are we considering these drones that will have a single subscription, or they will have multiple subscriptions? Will they be all belonging to the same home operator when roaming, or multiple home operator? All of these aspects will definitely not define in 3GPP. That will have to be done outside 3GPP, because it will become some form of how to description of how we use these tools defined in 3GPP. And as an example, the ACJA has already looked into this, and we will be taking up the task of identifying which of the scenario and which of these tools are relevant, and how they can be used specifically for the aviation field. Next slide. Integrating sensing, as I was mentioning, I think you can go to the next slide directly. This is a set of tools that is being created for a variety of use cases, and the main use of the sensing capability that the radio network will be defining are detailed tracing of the UAV flight trajectory, which could be used as an example for compliance verification. So we know that we may have a certain flight plan that the device needs to follow. It may not always be following correctly. And yes, we have very reliable location mechanism, but this will introduce a whole new dimension of how that tracing can be done, and it will be much more precise. This can actually help very heavily with avoiding UAV collision or any type of confliction, with the ability of the network to collect this information and plan ahead depending on the obstacles that can dynamically enter and exit the flight path. Intrusion detection is, of course, one of the main use cases, because this would go beyond the idea of just tracking the location of UAV. It will really be more used in I hate to bring it to that level, but it will be used very similar to a way that the radar system works, but with a much higher precision than what we have in the existing tools. And there are also use cases that have been defined for UAVs detection. This applies also to generic vehicles, but it works very well with UAVs, especially near valuable target. As smart grid equipment is the example being used in 3GPP, but it would be the idea of using sensing to detect when flying vehicles get very close, or in an authorized or unauthorized fashion, to sensitive equipment. And the smart grid equipment was one of the use cases raised here. You can go to the next slide. So here I just defined, provided some definition of what is really sensing. So sensing is really the ability to use the radio signals that the RAN can capture to act in a form of radar. And we will have, of course, in this model, both a sensing receiver and a sensing transmitter. The receiver is any entity that receives the sensing signal. Notice that these could be both a RAN node, or the UE, so the flying vehicle itself can be a sensing receiver. And then transmitter is, of course, the entity that will be sending this signal. And again, the transmitter can be both the radio access network or a flying vehicle. And the idea would be that by using these RF signals in a radar fashion, both mobile devices and the infrastructure can create a detailed map of what is in the surrounding. Next slide. So here are the use cases, as I was mentioning, detecting the flight trajectory and monitoring it very closely. And notice that these include both devices that may be 3GPP devices, may have a SIM subscription, but these can bring into the picture also other type of drones that do not use cellular connectivity, that may be in a visual line of sight, and maybe using other RF technologies between the controller and the drone. All these would be visible by using sensing and collecting this information. Collision avoidance sensing goes beyond avoiding just collision between flying vehicles, but it's also collision with other obstacles. Could be tall building, bridges, it could be other moving vehicle. And intrusion detection is probably one of the most common and most interesting use cases that many parties have identified to be used for sensing as a solution for flying vehicles. Next. I don't think we need to get into the KPIs, but the 3GPP has defined some very detailed KPIs for the sensing, and these focus more in the distance of the sensing, the reliability and the accuracy of the sensing, and they go down, if you look at the numbers, to quite a detailed level, and once realized, it will bring in a very high definition view of the environment around flying vehicles or on the path of flying vehicles. Next slide. So what do we need to do next? So as I mentioned, this was the release 19 requirements and use case planning. Now we need to ensure that we can get this work done and get standardized. So if you go next. I would like, I put this slide here because I think this is a very important slide. So for those of you that are not familiar, this was the ecosystem overview that the ACJA defined. This is a published document. You can go to the ACJA webpage and download it. It's the overall UAV landscape framework. And as you can see, it's a complicated picture because it's a complicated environment. It's a complicated ecosystem. We need to start realizing some of the building blocks that are here by reusing 3GPP building blocks and by leveraging the requirements work that was done in release 19. Next slide. And one of the examples of these is this connectivity redundancy that the ACJA has identified as one of the key points to provide further reliability of the connectivity. Next slide. And I asked the question, what do we need to do? Well, we need to continue enabling these 3GPP tools in the work that we're doing. And I think ACJ is one of the works that is doing, the groups that is doing this. As a reminder, for those who are not familiar, ACJ is a joint work for aerial connectivity between GSMA and GotoMarket. And the idea is that we need to continue this work, especially in identifying which of these 3GPP tools can be used and how. And the idea is to provide how-to papers and detailed description papers that then regulators can use. Taking 3GPP specifications that are somehow very sterile and often abstract, and having regulators and the important parts that are doing this work adopt them is very difficult because they're very difficult to understand. So ACJA is doing this work in supporting various groups. As an example, we're working very closely with Eurocae. We have some work that we will start doing with other groups, but that work so we surely needs to continue. And the other work we need to continue is that, as I mentioned, release 19 has done some good works in defining requirements for some very important building blocks. We need to now make sure that we get that work done in 3GPP, both at the system level and the RAN, to enable this work to continue forward and implements the building blocks to define this next step of connectivity and UAV framework in 3GPP. And that's all from my side.
Thank you, Stefano. I wish we have 1 more hour to go, a little bit slower pace, but we knew what we were dealing with. You give us the hints, definitely something that we hope the auditorium will be in position to do a little bit deeper dive on available Autodesk GA material. But this really answers a lot of the question around as you stated, what's next, what's already pre-planned, and it got to work for us for quite a few years ahead. Thank you. Okay, so Barbara, with this, I probably would love us to all turn the camera, those that are a part of the session, and start addressing some of the Q and A portions. There's a lot of prepared questions. How do we start? Do we go first with a list of the stuff that were anticipated and then go to the auditoriums ones, or we take the auditoriums ones first?
Just pick one, then I will pick another one to distribute it. Go for the first one. I leave it to you to choose.
Okay, let me just go briefly. So maybe one question for Peder and Connect 44 team. What is the relevance for you to have a commercially authorized approved network for drone operations?
Good question. I think that moving forward on this journey, it is critical to have a platform like this where you can have all your flights listed, you have your drones listed, we need to have as approved platform where you can actually manage, control, and perhaps have other authorities to look over our shoulder and make sure that the drones in the air are authorized and okay to fly. What we feel at the moment using apps or other platforms for flying is it's not really authorized, and there's a lot of questions being asked today when we go fly because of many reasons and because of a situation in the world at the moment. But we have had a lot of unauthorized drone activity, and a platform like this would help filter through what is authorized and what is not. So I see it as a very important platform for the future.
Thank you very much. Barbara, you want to address the next one?
Yeah, I'm going to pick one very difficult. Oh, Mr. Su, you want to have a add-on a question?
Yeah. I have a question for Ericsson. So
sure.
I'm come from China Mobile. So I ask the question: what is the most popular use case when Ericsson deploys the drone services for your customers? Thank you.
So I can take that to you. It depends on, of course, the enterprise needs, and of course, what market are they really operating in? Because some markets do have quite a good regulated environment. Others are still struggling with that regulations to get on board. And I'll give an example here. The work that we did with TDC in Denmark, although it was more from a limited environment perspective, but the use cases were enormous. For example, what Connect 44 was one of our trial customers where the inspection was a good use case. The other one was media. So the TV2 was another a big media house that is currently using, let's say, helicopters. They wanted to deploy drones to do the live video streamings. Then, of course, mobile operators play a very important role, not only in terms of connectivity, but perhaps the requirement was on network slice. So there are multiple use cases that we've been seeing working closely with enterprises. But just to answer in terms of what do we see absolutely near term is the inspection use cases, especially on the vertical structures, whether it's towers, whether it's windmills, or whether it's construction. Because I think that limits a lot of requirements on the networks and regulations. So that's what most of the enterprises are currently asking us.
Thank you, Kapil.
In my experience in China Mobile's most popular use case, the first one.
Oh, Mr. Su, you muted yourself accidentally. Sorry.
In my experience in China Mobile's most popular use case, number one is emergency scenario. Number two is surveillance and inspection.
I think you've gone muted again, you. But I agree with you there as well. You in our trials with public safety the video that you saw on Ericsson Drone Mobility came from Sea Rescue Society and firefighting. But I think there the limitation is a little bit more on the drones as well as the networks in terms of the right coverage in those areas. But you're absolutely right. I think the public safety and the first transponders are the use cases which would see the usage of drones right away, as long as there are few elements available.
Yeah,
Yep.
if I might chime in, of course, the use cases depend a lot also on the geography and the location. In different parts of the world, the use cases are very different because sometimes we seem to focus mostly on urban developed area type of use cases. But if you look as an example, there are huge fleet of drones flying in Africa for goods delivery, like medical delivery. I mean, the number of flights is actually staggering, but we don't really see it or hear about that very often. In North America, as an example, in the use case, well, North and South America, the most common use cases, again, public safety and first responders, absolutely, is the one where there is a lot of ask, and sincerely, there is a lot of money because inevitably government are investing a lot on that. And coverage is absolutely an issue, and that's, as an example, a scenario where a 5G private network, we believe, will provide some answers because, as an example, I can give an example, California wildfires. They are in rural area, you don't have coverage up there, but the fast and dynamic deployment of 5G private networks will provide you that coverage. So those scenarios are very challenging, but also very interesting, and they are a perfect test case for a lot of the technology that we're talking about. Agriculture. A lot of the agriculture maintenance, from spraying chemicals to monitoring crops, especially in areas in countries that have a large agricultural industry, are very important. And the third one, infrastructure surveillance, inspection, and all of those are definitely most of them. I think this industry started at the beginning thinking about the drone package delivery and things like that as being one of the biggest, most urgent use cases. Is turning out actually not to be one of the biggest and most important, because all these other are actually prevailing. But those are definitely, I would say, the first three. First, agriculture, emergency first responders, and infrastructure surveillance.
Thank you, Stefano. Stefano, we have one question for yourself. What needs to be done to enable ACAO and FAA C2CSP model via cellular networks? If you can comment a little bit.
That's actually a very interesting aspect. It's a question that we have in a CJA, and with the landscape document which I mentioned is already published, we are already providing some answers. Now we are actually working on defining that much more in detail. We think so. The ICAO, FAA, and other civil aviation authorities have defined the C2CSP model, but of course, it's defined at the level of requirements and high-level views. Now we need to really do the work of how do we make this happen in reality. So we know the framework. We need to work. We need to know. We have the question that we need to answer. How do we use the tools available? Some of them are 3GPP tools. Some of them are tools that need to be created by the aviation industry. And I think that's why I think the SCJ work is very important, because we need to write on how to set of documents that capture both the views from the 3GPP world of what cellular network can provide, what cellular devices can provide, but also from the aviation, because there will be building blocks that are outside traditional work. So, as an example, the EDM work is very important because what they provide is not actually a function of a 3GPP mobile operator. It's something outside the mobile operator that interfaces closely with a mobile operator. That needs to be captured, and all these pieces needs to be defined, how they can work together, and what they need to do to be able to interface. So all of this is a work that needs to be done in order to capture quite clearly what are the building blocks, how they can be used, and how they should be realized.
Thank you, Stefano. The next question I came across.
Sorry, Alexander,
yes,
can I add one thing? In my experience, it's very important to do this work, sometimes perhaps going a little bit beyond the set boundaries of this work, because regulators, I can mention various scenarios, but regulators don't necessarily understand how cellular network work it to the minuscule detail. So they need some help to see this black and white on how they can be used. And based on that, they can make more informed decisions. So we can help a lot, and I mean, all the members here, all the people involved in the discussion, we can help regulators in identify how these blocks can be used. So that is a very important work that needs to be done.
Thank you. There's one more question from the auditorium that I think is important. How exactly will 5G enhance the security when it comes to the UAS ecosystem? So it's probably a combination of if we can get 2 cents on it from Stefano and someone from Ericsson team.
I can start here a little bit.
Go ahead, Fredrik.
Depends also when we say security, if we talk about aviation security and ground risk mitigation, I mean, we will bring parts of this network intelligence out to do the proper risk mitigation. And then we have data security, which is kind of also addressed here by having encrypted end-to-end links, reusing parts of what already exists in 3GPP when it comes to encryption and data security. And then we also can address the security of the data that we capture. I mean, that's, I think, the most sensitive for the end users. How do you treat that today? So maybe it's not the typical 5G functionality, but by introducing telecom 3GPP technologies, then we will enhance that as well, I believe. So there are many different aspects.
Yes. Yeah, it's probably broader for how does cellular rather than just a 5G specifically address it. Anyone else want to chip in on that one?
Yeah, if I can add on top of what
Sure.
Fredrik said, as an example, if you look at what 3GPP did in release 17, one of the big points is, okay, so you have a mobile operator that has a device, that has a subscription, so it's an aerial device. The mobile operator can, of course, verify if the subscription is valid, but doesn't have the information to verify, is this actually an authorized drone? Was it built according to regulation? Is it certified as a hardware? Because of course that's not the role of the mobile operator to do so. So the framework for authorization and authentication that was defined was to enable mobile operator to allow flight only for devices that the UTM or the USS authorizes. So yes, this is actually a valid drone, is certified, is registered with the aviation authorities, and yes, it is authorized for flight by UAS operator that has its own certification and so on. So all of those will add a lot of security on top of these. And once these features are implemented, especially in 5G systems, that will introduce at least all the security in terms of ensuring that the devices that are flying are actually authorized devices.
Yeah.
If I may also add, it depends on the question, what was related to. So it's a very broad question. Is it compared to what? Compared to the existing technology. So if you look at Wi-Fi, we mentioned, if I just look at the drones, and the drones at the moment are using Wi-Fi. So the first step is, first of all, you're using security hardware, so it's the same. And already there, you store information on quite a difficult access on the SIM instead of memory or extractable memory. You use a spectrum which is licensed instead of unlicensed. Already that is giving you a higher security. And it's not just 5G. I mean, this is with just a jump that you will have from going to Wi-Fi to connectivity, which is cellular. There's also other connectivity, but to give you an example. And so on top of that, as you mentioned, Guy, there's a lot of other level of security depending on how you look at that. So do not forget that if you compare it to just using Wi-Fi, you have an immediate jump on the security, in my opinion.
Yeah. Thanks, Barbara. Lily, there is one question. Hopefully, you might be able to address it for us.
Yes.
For the lost link use case, do you mean the drone uses different spectrum or methods between the C2 and 5G video? Does the pilot uses 5G video to control the drone while using C2?
Yeah, sure. So actually, the spectrum-wise, so for C2 or use the video link, we can be using the same spectrum. However, on the network-wise, we can also providing high priorities or high qualities to the control signaling. So in that case, it's actually C2, of course, are needed, but also the video streaming remotely that will be helping the remote pilots to identify basically to see any kind of things, basically blockage or any kind of obscurates that has not been identified, or that will actually improving or definitely helping on the remote pilots on BV loss. So I would say both are needed, and basically we can be from a 5G on that aspect. Actually, we can also giving a more enhanced liabilities with the 5G technology, definitely onto the in the connectivities. So that actually is one of the very key thing also for the your earlier questions on the security that 5G can improve.
Thanks, Lily.
Excuse me, Alexander. I have another
Yes.
question for Ericsson.
Sure.
Okay.
Go ahead.
So I have a question: is the onboard terminal for 5G network? Just now, the first presentation, the video broadcast shows Ericsson has a solution for the beware loss. So first of all, we need a terminal, a 5G terminal can receive the 5G radio signals on board the drone. So these terminals is made by yourself, by Ericsson, or by your ecosystem? Is my question. Thank you.
Yes, definitely. So I can take that question. So that we have the partners basically also from the ecosystems, and all the drones actually we are using are not made by Ericsson. So all actually are provided by our ecosystem partners that has been either using open source to build the build the 5G capable drones, or there was of course that there would be also cases that the people are using the offshore. Actually, some of our partners are using DJI drones, and then they actually have some on, let's say upgrade or modulation on that. So that there is so all the drones that actually we are using are either commercial off the shore or off the shelf, or also from our eco partners.
Okay, and the flight management. Oh, sorry. Flight management platform is developed by Ericsson yourself or your ecosystem?
Am I get your question correct? So you're referring to the Ericsson drone mobility platform, is that correct?
Yeah. The platform can control the drones takeoff or landing.
Yes, correct. Yeah, that is developed by Ericsson team.
Okay.
So, just to clarify, here, Ericsson drone mobility. Of course, we don't make drones ourselves. The whole intent is, as and when I think we have Stefano from Qualcomm here, he can share more his insights in terms of as and when the drone manufacturers are getting the 5G enabled drones on top of their SDKs. But what Ericsson drone mobility does is we understand telecom, we understand the intelligence, and I think that's what Frederick and Lily have been sharing. So the whole point is, how do we expose those intelligence and APIs to maneuver the drone in a smart way? And I think you're right, so it can only happen once the drone tries to understand through 5G, how it can be maneuvered. So some of the drones, it could be retrofitted. Some of them are off the shelf as well. But at large, we're missing that piece in the ecosystem puzzle, where the drone manufacturers should start thinking about incorporating the 3GPP standards on top of a drone. I think then the market potential will completely be different.
Thanks,
Thank you.
Kapil. We probably have time for one more, I think, for Peder, if you are in a position to address it. From the perspective of C44's services and solution providing capabilities that you have, if there is any failure while operating the critical inspection or operation, then how it is managed to keep the operation and how the downtime affect the enterprise?
So if I understand this question, in case connectivity is lost, yeah?
Yes.
Okay, honestly, we haven't experienced that. Typically, what would happen, the drone would return to the starting point. That is what normally happens. So it knows from where it takes off, and that is the homing point in case connectivity is lost. And typically, it happens on the apps I was talking about previously. The platform we have not experienced this outage on, but I would assume that the same would happen if connectivity was suddenly lost. The drone would home back and land, or we would gain control on our remote control.
Thank you, Peder. I have actually experienced lost drone in some of our aspects, and the programmability to get back was not kicking in as per standard. So we had a lot of questions transferred to our local drone regulators. Actually, have mounting of the drone.
Just to add to this specific aspect, and I think Stefano, you're working on a lot of regulations as well, or standardization as well. I think the whole concept of where the mobile operators can really help in this area is, when the 3D coverage maps are available as well. So at least the authorities who would approve the permits, they base their approvals on something more credible coming from the networks. And I think that's where mobile operators can really benefit the drone ecosystem, because that information is already available. It's another matter that today, most of the networks are based on terrestrial network. We need to figure it out a good way for the coverage up in the air.
Yeah,
absolutely. Okay. And absolutely, Kapil, the operator can provide a lot of this information. Of course, it also comes down of how much information you want to make public, because of course, operator don't want necessarily that to be public. So sure. Sorry to mention it again. If you look at the work done in SAJ working task 2 with the network drone services, that's part of it. Because in reality, let's say, if you are a UAS operator, you don't necessarily need the operator to tell you exactly where the coverage is, what it is, and where it is. You need more of a green light, like, this is my flight plan. Will I get the necessary quality of experience on this flight plan? Yes or no? Or are there suggestions to have a different flight plan to get that quality of experience? So we're not, I think it needs to be very clear, nobody is asking any mobile operator to publish their 3D coverage maps to the world or any confidential information, because that is, of course, of consent of operators to do so. But via SLAs with the US operators, there can be some information published that helps with the flight planning. And coming back to the question of loss of connectivity, we also seen that it's actually quite rare, but it can happen. Things can happen. Especially, I can give you an example, in the urban jungle, we have seen scenarios where there can actually be loss of connectivity due to the whole buildings and something like that. And what happens in that comes down a lot to the regulation of the country where you're in and the level of automation of the flying vehicle. You can go from retracing your steps back to go back to base, to hover in place until you get connectivity for a certain time, to force landing in a safe area. So there can be multiple things. And if the level of automation is high and it is authorized, in many scenarios, actually nothing needs to happen. Because let's assume if you are a drone that is carrying goods between two cities and you are in a low risk area, well, you can keep flying. because due to the flight planning and other solutions, you know that there is no obstacles on your path and the flight is authorized. You can keep flying for a while until you gain connectivity again. So there is a large variety of solution and the reaction that can take place. All depends, of course, on the local regulations.
Thank you, Stefano.
Yeah, I believe with this we are running out of time.
Yes, so I'd like to thank everyone who attended this deep dive today, the presenters as well. There are some questions, unfortunately, we're running out of time to address them, so hopefully we'll be able to address it in some other means. So Barbara, any closing remarks? Thank you, everyone.
Again, thank you, everyone. Thank you to the audience for everything, for the questions. We do our best to see if we can answer you offline. So thank you for that. Again, we will post, the session will be still in demand, so if you missed some of the parts, but the rest will also be available on the GSMA website. Here you have the link, and feel free also to contact ourselves. So thank you again for joining, and stay tuned for other sessions. Thank you, everyone. See you soon.